There we go. So then I'm going to go ahead and write down my two problems real quick, and then I'll switch back to the screen. Reset. And negative 5, 7. Okay. All right, so here's the two problems we're going to start with. Obviously, these are a little more detailed than what we did in the warm-up. All right, so hopefully you guys remember how to multiply fractions, that you multiply straight across the top, straight across the bottom. You do not need common denominators. But I'm going to teach you some little shortcuts that I like, because I would prefer not to multiply 5 by 66 and then have to figure out how to reduce it with 11. So when I do this one, and I write it like this, okay, I like to look for things that can cross-cancel, and cross-canceling here, 66 goes into, or 11 goes into 66, and so I can go ahead and say 11 goes into itself once, 11 will go into 66 6 times. And now my denominator is 1, and I just take 5 times negative 6, which is negative 30, and I'm done. Okay? I don't put negative 30 over 1. I mean, that's what it is. Every number is over 1, but the simplified answer is just negative 30. Okay? All right, then if I have 3 of them, I can do this the exact same way. So I'm going to say 14, I'm going to go ahead and put it over 1 here, times negative 3 over 5 times negative 5 over 7. And again, I'm going to look for things that I can cross-reduce beforehand so my number doesn't get so big. So obviously I have some 5 that can cross-cancel, because 5 will go into itself once, 5 will go into this 5 once. I also have a 7 and a 14. I can cancel those. So 7 will go into itself once, 7 goes into 14 twice. I had 2 negatives, so a negative times a negative will be a positive. I'm going to take 2 times 3, which is 6. And this is 1 times 1 times 1, so my final answer is 6. And that's it. So I just want to do a quick review of those with you before I moved on, because I thought you might have some questions if I didn't show that to you first. Do you guys have any questions about either one of those? That's all making sense so far? Okay. So let's go ahead and write down these next two, and I'll write them down on my paper also. Maybe. Hold on. Not one to click for me. There we go. All right, we're going to write down these 3 and then go over them. I realize they say A, B, and C again. Do these look a little crazier? Yes. Here you go. See if that helps. If you see it in my handwriting. On which one? On C? Yeah, you will no longer, by the way, see that ugly multiplication sign. It's not used anymore. The only time we'll see it is in scientific notation, but other than that, it's dead to us. Okay, he is dead. He's gone. He is dead to us. Him and Mr. Division. I always say Mr. Division sign is gone now too. We don't use him anymore. We use the fraction bar. Yep. All right. So looking at letter A, okay, this is now 5y over 1. So if I was to rewrite this, I would rewrite it as 3 over 10 times 5y over 1. Okay. And if you want to get really crazy, you can even separate out the 5 and the y, because that just means 5 times y. So you could actually even put y over 1 as the third thing. Okay, the same rules apply, because this is all multiplication. There's no addition or subtraction in here. This is why this works. I can still go ahead and cross-reduce. Okay, so I can cross-reduce 5 goes into itself once, 5 goes into 10 2 times, and now I can go ahead and multiply straight across the top. So I have a 3 times a 1 times a y, which is going to give me 3y. 2 times 1 is 2. So you can read this as 3y over 2, or you can read this as 3 halves times y, okay? But if you have the y cannot go in the numerator. It's either, or I'm sorry, in the denominator. It's either 3 halves times a y, or it's 3y over 2. But the 2 can, or the y cannot go in the bottom. Deshaun? Go on.
These are the ones that you can't, like, make them.
You could make that into 1.5y. There just wouldn't be a reason to.
How would it be if
It would be 1.5y. Yeah. There would be no reason to on this one. All right, so let's look at letter B. I have a negative 7x times 3.5 times a 2x. So everything here is straight multiplication. Probably what I would do, because I like to do as much mentally as I can, I would probably go ahead and take 3.5 times 2, because that will give me 7. And then now I can take 7 times negative 7 and get negative 49. And then you guys should remember this from last year. If I have an x times an x, I get x squared. That's not new, right? You guys have seen that before? Okay. All right. So, letter C. Again, this x, if he's out to the side like this, he is in the numerator. He cannot go in the denominator. That's just the one thing you need to remember. So this would be like negative 3/4 times an x over 1 times a 2/3 times a negative 5/1. And then I like to look for anything I can cross cancel so I don't have to work so hard. Looks like 3s are the only things that are going to cross cancel here. So, oh, 2 and 4. Good call. I missed that one. And 2 and 4. Good. So 1 here, and this will turn into a 2. And now I can multiply straight across the top. I have a negative and a negative, which is going to make this a positive. Okay? And then to put them in the correct form, the number goes in front of the variable. So we're going to write positive 5x. Okay? This is called the coefficient of x. Numbers can't go behind it unless they're exponents. Okay? And then we multiply across the bottom, and all I'm seeing here is a 2. So you could read this as 5x over 2, or you could read it as 5 halves times x. Either way, those would both mean the same thing. Okay, you guys still doing okay, or do you have questions for me? Making sense? Okay, you did not see this stuff last year, is that correct? Haven't seen them like that? Okay. All right, let's write down the last slide. Oh, that's a little hard to see. Okay, and you don't have to write down everything, so let's just abbreviate. We can say we're going to evaluate, and then go ahead and put x equals negative 2.5, y equals 1.2, and then we'll write down the problem. All right, there we go. All right, so evaluate just means to plug in and simplify. So we're going to start here and put in the 1.2 for y, minus 5, and then we're going to plug in the x, which is negative 2.5. Oh, I don't know why I'm doing that. Okay, now, here's what's tricky. This is why I like to change my signs, because if I don't, I feel like I make silly mistakes. So we know that this does not mean subtract 2.5, because these two were touching. We know that this is multiplication. I would probably go ahead and change that to plus a negative, so that I know that when I multiply these two together, I'm multiplying those two and I'm going to get a positive answer. So I've got 5 times 2.5, which is 12.5, and it's positive, and then I'm going to add the 1.2. And so that's going to give me, what, 13.7? So that's what you have to be very careful about. I always have people say, is that a subtraction sign or is that a negative? And I'm like, yes, it's both. Because if I cover this up right here, you see a negative 5. Okay, so it is a negative 5 times that. Questions on that one? All right, so the last one we're going to look at, so on this I'm going to plug in a negative 2.5 here. And I'm going to plug in a 1.2, subtract out 10.8. Alright, so I have this number times this number, so 2.5 times 1.2 is going to be a negative 3, because I had one negative there, and this is minus 10.8. These are both negatives, so I'm going to add them together. Again, I like to change my sign here to say plus a negative, and then that just tells me I need to add those two so that I get negative 13.8. So basically, A and B are combining everything we've done in 2-2 and 2-3 and now 2-4. Okay? All right. I don't want to get out whiteboards for 3 problems. So here's what I want you guys to do. I'm going to say bye-bye video.